Okay, so lesson 2 of this unit, lesson 2 of unit 2, is on the mole. This is a very important concept that you need to understand to be able to be successful in the rest of the unit. First thing you need to understand is AMUs, or atomic mass units. So essentially, protons and neutrons have masses that are approximately 1 AMU, and electrons do not contribute to this mass. If we define the AMU of having a mass of this number here, 1.66 times 10 to the negative 24th grams, we can see that atoms are extremely small and have extremely small mass. So 1 AMU is defined as this value here, 1.6 times 10 to the negative 24th grams. Okay? So this just example here just talks about how if something has 17 protons and 18 neutrons, it has a total of 35 AMU because we ignore the electrons since they don't contribute significantly to the mass. So as you can see, this mass is very small, so it's 5.81 times 10 to the negative 23rd grams, and this kind of reflects back on the fact that atoms are very, very small, so we have to be able to talk about them in a bigger quantity so that they can make sense to us. One atom, to talk about it, would be so small since it only has a mass of 5.81 times 10 to the negative 23rd grams. Because of that, we talk about this quantity called a mole. So you might think of moles as the animal, or maybe the thing that you might have on your skin, but this is something else referred to as a mole. A mole in chemistry refers to, essentially it comes from the number equal to the number of carbon atoms in exactly 12 grams of pure 12, or carbon 12. But what you need to know is if you say a dozen, you know there's 12 of them. If there's a mole of anything, you know that there's 6.022 times 10 to the 23rd units of that thing. This is called Avogadro's number. There was a scientist involved in making this claim and this discovery here, but essentially this came from 1 mole of carbon having this number of carbon atoms. What you need to know at bottom line, 1 mole contains 6.022 times 10 to the 23rd particles. That's this many particles. As you can see written out here, it's quite large and it's kind of hard to wrap your head around, but just think about if you think about a dozen as 12 of something, a mole means this many of something. So if you take 1 mole of chlorine atoms, they have a mass of this value here, so essentially you would take the mass of each individual one, multiply it by the mole here, and get this value in grams. We'll talk more about this value later, but right now what you need to know is that 1 mole contains 6.02 times 10 to the 23rd particles. So for practice here, we're going to calculate the number of iron atoms in 4.48 mole sample of iron. So the first thing you need to do here is essentially you want to set up this problem using a T-chart, so that is something we can be going back to this entire time. I'm going to switch modes here just so I can be able to write on this. And a general rule of thumb, you want to keep 3 digits in the answer as we work through these type of problems. So, to calculate the number of iron atoms in a 4.48 mole sample of iron, so what you need to know first of all is that we have, this is going to be not the best writing here, so 4.48, so this is moles, so I'd set it up to say moles. Okay, and then a T-chart kind of looks like this. So what we're going to do is we're going to make sure our units cancel the entire way through. So we're going to set up this chart that looks like this. In each of these spots, you're going to put some other number that you're going to use as conversion. Nothing's going to go here because we start out with this known number we're given. So we need to decide the number of iron atoms in a 4.48 mole sample of iron. So whenever you have a mole, you can write your conversion as 1 mole. Mole is abbreviated MOL. So you might not abbreviate it, might just write down MOLE, but MOL is the abbreviation for mole. Alright, and then in 1 mole of anything, there's 6.02 times 10 to the 23rd. Again, I apologize for this writing, I'm doing it with a cursor. So 10 to the 23rd. And then I generally like to label these. You'll see why later when we get into more complex conversions, but I would label something after this like atoms here. I'm not going to do it since I'm using a cursor, but I would generally write atoms here. And then you would just go ahead and do this calculation. So remember, when you do this on your calculator, to be careful with how you enter the 6.02 times 10 to the 23rd. If you have a calculator that allows you to do E for times 10, that would be great. So 6.02 times 10 to the 23rd times 4.48. So your answer here is going to be around comes out to be 2.69696 times 10 to the 24th. I just use as a general rule of thumb to keep 3 digits, so 2.70. And then don't forget that this whole thing is times 10 to the 24th. That obviously makes a big difference. 2.70 is very different than 2.70 times 10 to the 24th. Okay, so that would be your answer. So you might want to label this to say atoms again here after it. Again, I'm not going to, simply because I'm using a mouse to do this writing. But then in the notes packet, you'll see there are plenty of other problems, so you can just go ahead and try some more practice problems, but that's generally how you'd set them up. So you just use the conversion. 1 mole is 6.02 times 10 to the 23rd, and go ahead and give these a try and see how it goes.